And also the rotational speed, we first tested the external electric field, which means we set the electrolysis voltage as constant and we elevate the external electric field. And here's the figure. We can see the higher of the external electric field, the faster it rotates. And also, the higher the internal electric field, the steeper the slope you can see here. And these three straight lines are experimental lines, and these dashed lines are the theoretical line. And we can also see the experimental line matches the theoretical line very well. And then it's the rotational speed with the electrolysis electric field. And here's also the figure. We can see also the higher the electrolysis voltage, the faster it rotates. And we also see that the higher the voltage of two plates, the steeper the slope. You can see here. And this dashed line is also the theoretical line. And this straight line is also our experimental line. And we also tested the density, the viscosity, and the conductivity. And we tested under the external electric field is 400 voltage, and the electrolysis voltage is 300 voltage. And we can also see here, this is the conductivity since we add the salt to it. And here's the angular velocity. We can see that the higher the viscosity, the slower it rotates. But the speed rotation will not change with the conductivity, which you can see is almost as a constant. So I believe the ionization theory is wrong to my theory. Yeah. And here's all the conclusions we've got. We first tested the threshold of the rotation, and we get the electrolysis electric field, and the external electric field should reach a constant, and higher the proportion of the glycerine, the lower the threshold, and the liquid film should be polar liquid. And for the polar liquid, the dielectric constant has slight impact on the threshold in my theory. And the speed of the rotation, the stronger the external electric field, the faster it rotates. The stronger the electrolysis voltage, the faster it rotates. And the conductivity has no contribution to the speed. And the higher the viscosity, the lower the rotational speed. Okay, so this is all my presentation. Thank you.
Thank you very much. We move straight on to questions from the opponent. Again, can I ask you to introduce yourself and
Good morning, my name is Rados Waszkiewicz. I have some questions. Did you vary the frame dimensions?
Sorry?
The frame dimensions. How big was the frame in different experiments? The same?
Yeah, the same.
Do you think it's a relevant parameter?
Sorry?
Is it a relevant parameter?
The frame, I guess it's no. It's not a.
Did you vary the film thickness?
Sorry?
Film thickness.
Yeah, we control the film thickness by the film interference, using the film interference. Yes.
Okay.
We controlled it.
Do you have the measurements for the film thickness in your presentation?
No, it's a little bit too hard for us to measure it, but we controlled it using the principle of the film interference.
Thank you. Did you vary the soap content?
Sorry?
The soap content. Did you change it?
Soap content?
Yes, add more soap to the water. Maybe later then.
Okay,
Did you
we could discuss
change the
about it,
orientation of the frame with the gravity? I mean, horizontal or vertical frame?
We just tested.
Yes, you tilted it. Did it have any influence?
Sorry?
Did it have any influence?
What influence? You mean
on the rotational speed?
Sorry, can you restate your questions? I can't hear it quite clearly yet.
Did it have any influence?
What parameters?
The inclination of the frame.
Yeah, we tilted for 5 degrees and we set it as a constant. We didn't change it.
Is it a relevant parameter?
I believe yes, but we didn't do it in our experiment.
Did you investigate temperature influence?
The temperature, I believe, is constant in our experiment.
Did you measure it?
I believe it has slight impact on the rotation.
So you didn't try with rectangular frame, if I understood correctly?
And in my theory, the temperature has no contribution to it.
Thank you.
Okay, thank you. You have 3 minutes to prepare.
不，他刚刚说的是那个 inclination of the。
不是你第一个问题，说 frame dimension，frame 的大小。
哦 ，frame 大小是有影响。
那你说没有影响？
我开始没听你他说什么。
不是你没听懂，你不要说。
哦，行行。
Excuse me, can I ask our audience to try and stay quiet? The teams are still working. It is preparation time. They do need to concentrate. There will be time to breathe and talk between our stages. So please bear in mind they're working hard.
然后还有那个厚度那个问题，你怎么扯？
就是我始终是对用干涉条纹。
对，他说用干涉条纹去控制这个。
他一定会死人问，因为干涉条纹是这样，如果你真正有物理常识的话，就知道干涉条纹只能测厚度和厚度差，对吧？谁说的呀？可以测厚度没问题。干涉条纹测厚度必须有标准样，没有标准样的话，干涉条纹。所
以我只能定性的去。
哎，不是哪瓶我？
你这是你看什么干？你可以通过它干涉的那个波长来，你给我写干涉条纹你。不是这两条等期呀，对啊，这上来对吧？这样写掉，你只要看它的这个干涉的这个颜色，看它拉达，所以说呢，这个东西几倍你知道吗？我也不知道，那你是几倍的不知道，你不是这个问题，你看这个所以要有标准样，要有标准，你要与之后主要看它的单一标准，不是单一的，它是同一个，它同一个，不是这个到底是一个长一个半的长有2万个。你不知道一个多长，你加那么多个条纹，你加那么多，你加那么多个。
就一个是frame dimension，稍微重申一下，对。我在threshold那边，因为边缘是变成太上，这是在threshold那边。对。不影响，但是我没有研究厚度的问题，因为让它那个厚度，因为你想，你如果是那样的话，有个重力影响，对不对？
Okay, you have 4 minutes to present your critique. Any remaining time within that 4 minutes is added on to discussion time.
Welcome, ladies and gentlemen. My name is Rados Waszkiewicz, and I'm glad to represent Poland. I'm going to oppose task number 4, liquid film motor. In the problem content, we found that the several parts are essential to understanding of this phenomenon. That would be the soap film, for instance. It is very important to understand what properties of the fluid make it even possible for the soap film to exist at all, and what are important for the rotation of the film. So I think it was investigated somewhat because the reporter varied certain parameters of the fluid, such as viscosity, but just the formation of the soap film should be at least mentioned in the presentation. In case of electric current, I think that the phenomenon of electrolysis is essential for understanding the whole subject of the liquid film motor, as it's the only way to add the energy into the system. There was no discussion of charge carriers in the liquid film, so I think this is a huge con of the presentation. In case of the film rotation, I think we've seen some qualitative description and even a quantitative model taken from literature, which I think should be discussed in more detail, but it's a good addition to the presentation to present what angular velocity do we predict. So in detail, as the pros of the presentation, the polarization introduced as the most important parameter. It's a good thing that you did this because it's the most important assumption of your theoretical model, at least in my opinion. You mentioned the importance of the gravity. You said that it's a relevant parameter, but you didn't vary it within your experiments. You just inclined the frame and said that this is important. you varied important parameters, such as proportion of glycerin, angular velocity distribution was measured then, and external electric field and electrolysis voltage were changed. These are the very important parameters in case of this whole problem. You discussed different liquids with different viscosity and conductivity. As I mentioned earlier, changing the liquid is very important.
Excuse me, can the reporter stop changing slides? It is the opponent's time at the moment. The reporter, can you please stop? Sorry, can we? Okay.
Thank you.
Continue.
So in case of different liquids, it's essential to vary the liquid to understand the phenomenon properly. So in case of cons, I think that the velocity measurement was vaguely introduced in the presentation. I don't really understand how did you measure the angular velocity. I think that you should say why this method with the CCD camera is a good method, why you obtain a result that you can compare with the theoretical model. What's the vertical velocity distribution in the film thickness? You didn't say anything about the film thickness. I don't know at this point from your presentation, is it a millimeter width or nanometer width? We didn't have even an order of magnitude. So you didn't say what is the origin of the yield stress. It's a weird phenomenon for the fluids to have one. So I think it should be properly introduced in the presentation. Also, you said that the conductivity is finite, so the Joule heat should be included in your presentation, as it would heat up the whole fluid and limit its time of operation. So as the points of the discussion, I would first of all like to discuss your theoretical model of the uniform torque, and then go directly to your measurements of the rotation speed to learn your experimental procedure. I would like to invite the reporter to the discussion.
Okay, thank you. Add those few seconds to the time.
So could you go to slide 20?
So first I want to explain something. You just asked me the dimension of the frame will have impact on the rotation, right? And I just didn't quite clear what the dimension you are referring to. But if you are referring to the size of the frame, it will have impact on the rotation. Yes,
yes,
I just want
thank you very much.
Yeah,
could you go to slide 20?
Yeah, okay.
So maybe a slide earlier, where you introduced the talk. Sorry for the inconvenience.
Okay.
You said that there is a possibility of determining the torque acting on the whole liquid. If I understand your theoretical model properly, the torque at each point of the fluid is the same.
The same? I don't believe.
Does the value of the torque change with the place at which we are?
Yeah, of course it would change.
Why?
Because this is I apply the differential to where you can see here's the R is the distance between the point and the center, and
so
it
could you
changed.
show me a slide with your theoretical description of the origin of the torque?
Okay, origin of the torque.
The driving torque. Even earlier.
Just forward. Just. No, just. 前面.
Yes, the one
Yes.
with dipoles.
Just
Oh,
like
okay,
this.
thank you very much. If I understand this model correctly, what I'm making of it is that at each point of the film, we have a torque that it's the same, driving torque.
Yeah, driving torque.
So, in my understanding of classical mechanics, if we apply the same torque at each point, nothing rotates. You can make easy experiment with your pen at once. What can you say about this? What changes?
Well, I believe the cause of the rotation is because the external electrolysis electric field, and it will change according to the.
Focus on the torque. This is the main reason why I ask you about this. Would the torque cancel out? Because it's the same torque at different direction from the center of mass.
It will be different.
Okay, thank you. In my opinion, there is some fundamental flaw in this theoretical model which didn't allow me to understand the assumptions of the
Yeah, maybe
theoretical
you
model.
misunderstand it
there's no no net fork would appear on the center of
Sorry,
mass.
I would explain.
Could you go to your experimental research, please, and show me how did you measure the velocity of the rotation of the film?
Okay, will please check for the. Oh, sorry. Yeah, you can see here. You can see here, there is a CCD camera here, and it can record the
I understand
rotation
that
of the
it's measurement with
will
the
please
CCD
help-
camera.
will please let me to explain. Yeah, here's the CCD camera, and it can record the rotation, and it can get the BMP picture, and we use a program to test each translation of the pixel, the same pixel each time, and then we can get the velocity, and then we can get the angular
Can you
velocity.
explain what are the basis on which this program works? How can you be sure that this measurement is appropriate in the case of determining the velocity?
Well, I believe this principle is the same, approximately same to the like the software of the tracker. But I believe in this case, our measurement will be more precise. And in some articles we have referred to, they use the PIV, but we are not reaching enough to get this machine. So we can just use the CCD cameras, which I believe.
Okay. Yes,
yeah.
I agree that the CCD camera is a valid way to make a photograph. I'm
Yeah.
asking if it's a good measurement to use a CCD camera in that case. Earlier on, you said one thing about the colors of the film.
Yeah.
They relate to its thickness, not the velocity. So imagine a situation that the fluid
Yeah.
is still, and we have a wave that it's moving across the film. Then your program would say that the film is moving.
You just mentioned the thickness of the film.
Yes, I would say that if the thickness of the film would change due to some disturbances, then your CCD camera would perceive it as a angular velocity.
Yeah, I want to explain the thickness. Since we tilt the film a little bit like this, it is 5 degrees, and which means the thickness of the film will increase proportionally, and we tested the velocity each time when we see the same interference color in this area, which means the thickness of this area will be constant, and since it is increased proportionally, so we can...
now you're saying that the colors of the film are not changing at all with time.
Yeah, this area will not change.
So how can your CCD camera investigate the angular velocity with the change of color if the color is not changing?
No, you've just misunderstanding. Will please check here. You can see, this is the BMP picture, and there's no color on it. We just use the pixels.
So you use the grayscale to investigate it?
Sorry?
You use the grayscale image to investigate the angular velocity?
Yeah, we investigated using the pixels, not the color. Because I guess it's more precise way. The program will test the same pixels and gain the translation of it, and then gain the velocity and the angular velocity. Is that quite clear?
Your explanation is clear, but still I disagree with your method of measuring the angular velocity.
Well,
there is a second phenomenon that I would like to mention now. If we have a film of very small but finite thickness, the velocity profile would be not a constant value. We would have higher velocity at the center than the velocity at the very edge of the film.
You mean the air drag, right?
There are multiple phenomena that would occur on the surface, but the air drag is one of them.
Yeah, of course, and will please the appendix air drag. Yes, we've considered the air drag, and we used the appendix. Yeah.
All right. So you agree that this influences your measurement?
Yeah, of course, it will have.
So what do you really measure? The velocity in the
But I
center
believe
of
it's
outside?
really. You can see here for the Newton inner fraction law, you can use this equation. Do you agree with me?
Okay, I know you can
see-
calculate
yeah,
it.
yeah, well, please,
I'm not asking about the theoretical prediction about the value of the drag force. I'm asking about
Yeah,
if your
you mean
measurement
you
can
mean
be
the
trusted.
velocity change, right?
Yes.
And the velocity change is caused by the surface is because of the air drag. Do you agree
Gentlemen,
with me?
can-
Yes, I
yes.
agree.
So we tested the Newton.
Gentlemen, can you please allow each other to answer a question before you start another one? It's great that you're being very active, but make sure each can make their point.
Okay.
Thank you.
Okay, so we test using this equation, and we can get that F equals mu omega at pi r0 2, and the mu is about 10 to minus fifth,
Yes.
and the r0 is about 10 to minus 3, minus third, and the order of this number is far lower than the force dragged by the external electric field. So we believe the air drag will have slight impact. It will have, but it is too slight, so we can just ignore it. Do you
Okay.
agree with me?
I would say that it might influence your measurement
Yeah.
in a way that you didn't predict because there are faulties on the surface that are much more influenced
But
by
we
the
believe
air
it's
drag.
really slight, so we can ignore it.
Okay.
Okay.
So you mentioned that the electrolysis is important in
Yeah.
this phenomenon.
Yeah.
Could you show me your theoretical prediction about the electrolysis properties?
Electrolysis properties, it will add
Yes.
a current to the film, and
What current is flowing through the film?
well, I believe it's just, oh, sorry for the pen.
Here it is.
Yeah. Here's the film and the electrolysis. Here's the positive. Here's the negative. It has a current like this.
Okay, so you drawn lines that represent current. What is the charge carrier of this current?
Sorry?
The charge carrier.
Oh, yeah, the charge carrier. With the polarization, the dipoles are like this. Oh, sorry. And you add current to it, and it will have a driving torque like this.
What are the charge carriers that move, that cause this current to flow?
It's the